Today, games are omnipresent. On consoles and computers at home, on smartphones in your pocket, and life at big esports events. But, there is one area, where games have had only limited success so far. As a way of education in schools. Especially, subjects like mathematics or physics, where students often get frustrated with the theoretical aspects, should profit from the practical nature of gamification concepts. So, why aren't serious games used more often in schools? We believe that one big reason is that it is extremely difficult to develop serious games that effectively combine both the theoretical and the practical aspects. To help with this, we have developed the UFrameIT framework that takes care of managing the underlying knowledge interactively. This creates a new workflow of integrating the complexity of mathematics or physics and allows game developers to fully focus on the game interactions. Beyond this, we are building a toolkit based on this concept that will greatly reduce the amount of programming and may enable teachers to build game levels by themselves. A good example to demonstrate how our framework works is calculating the height of a tree via trigonometry. To do this, we first need a game world. It can be created just as usual, for example, with the help of game engines. In this case, we just need a forest and an NPC. One way to figure out the height of the tree is using the tangent function. To make this knowledge operational in UFrameIT, we formalize it with a special language called MMT, that allows interacting with the knowledge. Then, our framework just needs to connect the game with the knowledge base so that they can communicate with each other during gameplay. A big advantage of this approach is that it allows the reuse of knowledge. Integrating domain knowledge is a difficult process, and is often performed on a per-game basis. Especially for domains like mathematics, this is often very redundant since the fundamentals will always be the same. With UFrameIT, developers can use a single comprehensive knowledge base for their games. But even more important, UFrameIT is not just another library, its knowledge engine operates dynamically during gameplay and takes care of many interactions that otherwise would need to be implemented manually again and again. Let us dive right back into the game to see these in action. First, the player needs to collect knowledge about the world that can be used to solve the problem. The game won't allow us to simply use a measuring tape to measure the height of the tree because the tree is too high to get to the top. Instead, the player can define points to create a triangle. Then we can measure the distance on the ground, which is one of the inputs of the tangent law. Let's take a look at what the system has done in the background. Placing the points in the game world has placed corresponding items into the inventory in the user interface. All of these are managed by the knowledge engine, and the game UI directly mirrors that. Below, we find the description of how to solve the problem and slots where we can assign concrete values from the game world to the abstract variables. This window is directly generated from the formalized knowledge and serves as one way to interact with our knowledge engine. Other, more immersive ways will be added in the future. Developers no longer have to predefine paths that lead to success, as the knowledge engine itself can verify the validity of a solution and even apply logic to determine necessary steps to solve the problem. For example, after assigning the measured length, we can ask the system to show us the points that belong to the respective triangle. The player can then proceed and assign these points. The system will update the labels in the description accordingly. If the player is still stuck, he can again ask the system for further hints. In fact, both angles have not been measured yet. Luckily, our system can not only help assign existing variables but also generate previews of missing information in the game world. We leave the assignment UI and get back to work to measure the angles as shown by the system. Last, we assign the measured angles. As every slot is filled, we let the system verify our solution. As expected, our assignments are correct, and the system rewards us with the height of the tree, which we could now use to apply other theorems and solve further problems. Of course, we have now used a rather simple example and let the knowledge engine help us a lot. Our intent is to let developers configure in which cases the system is allowed to give hints to fine-tune the difficulty of the game or dynamically change it depending on the performance of the player. Again, all of these features are independent from the specific problem and they are available for all future games without any additional effort. Developing new games is only a matter of formalizing the knowledge once and then building game interactions as usual. And, with a sufficiently large knowledge base, the modularity of our approach will enable designing a variety of new games just by recombining these modules in different ways. UFrameIT is developed at the Friedrich Alexander University in Germany, which was recently honored as the most innovative university in Germany and is ranked top 5 in Europe. In this constellation, we have a constant stream of young talent that contributes to our project. We take care of the necessary know-how through direct cooperation between the Chair of Visual Computing and the Knowledge Representation Group Quark. With close contact to experts in didactics and digital teaching at our university, we have the means of scaling our project and bringing it into classrooms. In 2021, we want to build plugins for game engines, implement a full toolkit on top of our framework, optimize compatibility for Android tablets in schools, develop more sophisticated games, and have a variety of exciting research topics for students. By supporting our project, you will help move serious games forward.